When I was 4 or 5, adults used to go around and they'd peer down at you and say things like, "What are you going to be when you grow up?" This is me at 5 on a pony in Dublin Zoo in 1962. And I can tell you, I wasn't thinking about what I was going to be when I grow up. I was only interested in two things. Was this creature going to move, and how the hell am I going to get off it? One thing is for sure, I wasn't going to be a cowboy. You know, at 15 years of age, I had to start making some choices about subjects in the Leaving Cert. And only a year after that, I had to start thinking about career. And I kind of had this vague idea that maybe engineering might be something that I could get involved in. I started reading a bit about it, and I knew that architecture was connected to it. So, with the help of my dad, a visit was arranged to the office of an architect and an engineer on the same afternoon. I think I was in 6th year in school. I have to say, I found it rather difficult to grasp what the architect was talking about. I'm sure to his own mind he explained himself perfectly well, but somehow I didn't get it. I went around the corner into the engineer's office and I saw a different kind of drawing. The architect had showed me drawings of things that were actually quite recognizable. There were rooms and there were doors and there were windows and manholes and all these things that you can actually see when you walk into a building. And I went to the engineer's office and I saw a different kind of a drawing. It wasn't as cluttered and it was more orderly, but yet it was slightly mysterious. It was these heavy black lines, and then they'd become dotted and disappear behind the wall and then come out again, and they were connected in a kind of grid. And yet this whole grid was what held everything up, kept it all together. So we were looking at this drawing, and then I noticed to one side there was a kind of a crumpled sheet of tracing paper lying down on a drawing board, and I asked what was that. And the engineer, whose name was Kevin Clancy, told me it was a Maxwell force diagram. Oh, what's that? He said, well, the lines represent forces, and the length of the line represents the size or magnitude of the force, and the direction of the line represents the direction of the force. And this was used to calculate the forces in a roof truss. So here's a very simple example. In fact, this is the simplest possible roof truss. A single triangle. We'll put a load on it of 1 ton or 1 kilogram. Anyway, 1 unit. And it's symmetric, so the wall over here takes a half and the wall over here takes a half. And so how does a Maxwell force diagram work? Well, Maxwell laid out a recipe for naming it and numbering it. We won't go through that now. So, when you go from A to B, you have a force of 1 pointing down. So that's A, and that's B, and that force is 1. And when you go from B to C, you're coming back up a half, and when you're going from C to A, you're coming back up another half. So those are all the forces acting on the truss. Now, what we do know is the force in this member is in this direction, and we call it A1, and there it is like that. And we know that the force in this member, we call it C1, is acting in this direction. And there's the point 1. And we can just simply measure the length of that line relative to this line, and it gives us the size of the force, and the other one is the same. And that's a Maxwell force diagram. Very, very simple. Here's one for a slightly more complicated truss, and you'll have seen these trusses going up on houses, and you see bigger versions of them in railway stations and various other places. And there's the diagram. I actually thought there was something beautiful about this diagram. It was symmetric, and it had meaning. Every point on this diagram had a meaning. Every line had a meaning. The direction of the lines had a meaning, and whether they met at a point or not had a meaning. If they meet, the structure is in equilibrium. If they don't meet, it's going to fall down. What I could never have imagined at 15 was the fun and the excitement and the satisfaction of watching an idea start as a little pencil sketch, and then it's worked up into drawings, and then eventually working drawings, and then it goes out onto the site and the skeleton starts to grow up out of the ground like some bones of a great dinosaur assembling themselves in reverse, and then the muscles are put on it and the sinews and the skin. What a thing to see and to be involved in. But even more surprising than this was the satisfaction of doing something creative in a team. And I found that when I first started working with architects, I became quite curious as to how their minds worked. And what I discovered was, when I began to understand something of how they thought, that we could get onto the same wavelength, and then something really interesting would happen, and sometimes even something beautiful would emerge. It might be a small detail, or it might be a whole scheme. And that wasn't all. Along the way, one's understanding of quite simple principles becomes deeper and somehow more solid. And I found myself standing on firm ground, and I was able to make sound decisions, and bit by bit become fluent enough to sometimes become a little playful or even bold. I guess you could say I wasn't worried anymore about the pony moving. And then the unique privilege in my rugby-mad hometown of getting to lead the structural engineering team on Thomond Park. Now, I was an absolute dud at rugby, but I could play on a team that raised a great rainbow over Limerick City. And that's another story all of its own. So, having made this journey with some marvellous teachers and some fantastic companions, I've been stretched, I've been deeply satisfied. I've found far more richness than I could ever have anticipated. I wonder if after 28 years practicing as a civil engineer, UL came to me with a unique offer and opportunity. Here's a blank slate. Design a program. Create a kind of educational experience for civil engineers to prepare them for the great adventure. What might that look like?